Hello everyone and welcome to Brilliant Mind series, a new math tutorial channel designed for JHS 1 to JHS 3 and 7 to 9 grade based on the National Council for Curriculum and Assessment, Ministry of Education Ghana, West Africa and United States Department of Education respectively. The topic is Geometry and Measurement, Position and Transformation. This is part 1 of the topic. Part 2 will follow between 2 to 3 weeks. When a plane figure undergoes transformation through rotation, reflection, and translation, it means its position, shape, or size has changed. In this video, we are going to learn about types of transformation, reflection, and rotation. When you reflect a point across the x-axis or y-axis, the position of x and y coordinates remains the same. That's what you see here. It remains the same because it is being reflected. However, after you have come up with your formula, either the x or y will be negative. In the same vein, when you rotate a point through 180 degrees or 360 degrees, whether clockwise or anti-clockwise, the position of x and y coordinates also remains the same. After your formula, either x or y will also be negative. When you rotate 90 degrees or 270, whether clockwise or anti-clockwise rotation, the position of x and y coordinates change. As you can see here, xy now maps to yx. After your formula, either y will be negative or x will be negative. A reflection is a transformation representing a flip of a figure. Figures may be reflected in a point, a line, or a plane. Reflection can occur over a line and or in a point. These are some of the few examples of a reflection. As you can see here, this is called Cartesian plane or coordinate plane. X and y axes are called coordinate axes. X and y are called coordinate axes. In a Cartesian plane, it has 4 equal divisions by origin called quadrants. So we have 4. 1, 2, 3, 4. They are called quadrants. This is first quadrant, second quadrant, third quadrant, and fourth quadrant. In the first quadrant, x is positive, y is positive. In the second quadrant, x is negative, y is positive. In the third quadrant, x is negative, y is negative. And in the fourth quadrant, x is positive, y is negative. Clockwise rotation. We begin from first quadrant, clockwise rotation, from right to left. Anti-clockwise rotation, from left to right. Now here, we are going to come up with our formula. But first, we are going to come up with reflection in the x-axis or reflection in the line y equals 0, or using x-axis as a mirror line. First, just get a sheet of paper, cut it in the same shape like this. This is right angle triangle. Label this side x-axis and then label this side y-axis. Now, reflection in the x-axis or reflection in the line y equals 0, or we are using x-axis as a mirror line. So we are going to reflect this. Now after reflection, you could see that this side is negative and that side is positive. So y is negative, x is positive. Therefore, reflection in the x-axis or reflection in the line y equals 0, xy maps to x, negative, y. Let's go back. Let's move on to reflection in the y-axis or reflection in the line x equals 0. We are going to use y-axis as our mirror line. So we flip it. As you can see, x is negative, y is positive. And therefore, reflection in the y-axis or reflection in the line x equals 0, xy maps to negative x, positive y. So let's look at some few examples. reflection in the x-axis or reflection in the line y equals to 0. The mapping is given as x, y maps to x, negative y. This is called column form, and this is called coordinate form or ordered pairs. Illustration 1. The point Q, negative 3, 7 is reflected in the x-axis. Find its image. So this is the mapping. We are going to substitute negative 3 and positive 7 into the mapping. And so negative 3, positive 7 maps to negative 3, negative 7. Negative 3 in the question is here. And this is positive y, but y is now negative. So we have negative 3, negative 7. Therefore, the image of the point Q, negative 3, negative 7 is Q1, negative 3, negative 7. Illustration 2. Q1 is the image of Q, negative 2, negative 5 under reflection in the line y equals 0. Find the coordinate of Q1. We will still substitute negative 2, negative 5 into the mapping. We're going to have negative 2, negative, negative 5. Negative, negative 5 because in the mapping, y is negative, and in the question, y was also negative. That is why we have negative, negative. And this will give us negative 2, positive 5. Because of the negative, negative, it tends to be positive. And therefore, the coordinate of Q1 is negative 2, positive 5. Illustration 3. Reflect E, 9 divided by 2, 1 divided by 2 in the line y equals 0. This is the mapping. And so 9 divided by 2, and then negative 1 divided by 2. Negative 1 divided by 2 because y is negative. And therefore, when we simplify 9 divided by 2, we get 4.5. And then when we simplify negative 1 divided by 2, we get negative 0.5. Therefore, the image E is 4.5, negative 0.5. Then we come to reflection in the y-axis or reflection in the line x equals to 0. The mapping is xy maps to negative x, positive y, or xy maps to negative x, negative y. Illustration 1. Find the image of the point negative 2, 3 under reflection in the y-axis. This is the mapping. Xy maps to negative x, positive y. And therefore, we are going to get negative, negative 2, positive 3. Negative, negative because in the question, x was negative. And in the mapping, x is also negative. And therefore, we are going to get negative, negative 2, positive 3. And negative, negative 2 gives us positive 2, positive 3. Therefore, the image point is 2 and 3. Illustration 2. The point D, 0, 3 is reflected in the x-axis. Find the coordinates of its image. This is the mapping. When we substitute 0, 3 into the mapping, we were supposed to get negative 0 and positive 3. But we don't write negative 0, or we don't have it. We don't have negative 0 in mathematics. And so we have 0, 3. Do not attach negative to 0. And therefore the image point D is 0, 3. Illustration 3. Find the image of the point 5, 3 under reflection in the y-axis. Xy maps to negative x, y. And therefore x is negative, y is positive. And therefore you have negative 5, positive 3. And the image therefore becomes 5, 3 is negative 5, positive 3. Reflection in the line y equals x or y minus x equals 0. This wasn't actually part of the earlier syllabus. They just added this to the new curriculum by National Council for Curriculum and Assessment. This is a new topic that they have added. So the mapping is xy maps to yx or xy maps to yx. So we are going to look at a few examples under that. Illustration 1. The point Q83 is reflected in the line y minus x equals 0. Find its image. And therefore xy maps to yx. We interchange x and y. The position of x and y coordinate changes. And therefore we're going to get 8, 3. And therefore we are going to get 3, 8, which it was 8, 3, and then it maps to, we interchange it, so it's going to be 3, 8, and therefore the image Q1 is 3, 8. Illustration 2. Find the image of a point R, negative 1, negative 5, when it is reflected in the line y equals to x. And therefore, x y maps to y x, and that will give us -1, -5. That's the question, and this maps to -5, -1. We interchange it, or -1, -5, and that maps to -5, -1. Therefore, the image of R is -5, -1. And then we come to reflection in the line y equals to x, or y plus x equals 0. This wasn't also part of it. They just added it. The mapping is xy maps to -y, -x, or xy maps to -y, -x. So let's look at some few examples here. Illustration 1, the point P, positive 12, -6 is reflected in the line y equals to -x. Find P1. So we are going to have, this is the mapping xy maps to -y, -x. And the question is 12, -6, which maps to -6, -12. Negative becomes positive, and the -12 is here, or 6, -12, or you can also write it in a coordinate form. Hence, P1 is 6, -12. Illustration 2. Find T1 if the point T, -7 divided by 2, -7 is reflected in the line y plus x equals 0. And this is the mapping. And so when we substitute the values into it, we are going to get -7, then -7 divided by 2. -7 gives us positive 7. And then when we simplify 7 divided by 2, we are going to get 3.5. But it was negative and negative. That's how come we got positive 3.5. Hence, T1 is 7, positive 3.5. Now, there's a review exercise. You can try your hands on this. Make sure you try all the questions, just so you'll be able to know whether you understood the concept that you've learned. Answers have also been provided at the end of the video. Now we are going to learn how to plot points and shapes, that is, plane figures, with given coordinates in the normal plane. Now note the following. This is x coordinates, and that is y coordinates. 2, 3 is called, the way we write this is called ordered pairs or coordinate form. And then you can only plot a point when it is in this form. And this is column form or vector form. Students always leave the answers in a column form, and then they use it to plot. When you do that, examiners will subtract some marks from your marks. If you want to plot this, this is how it will look like. And this is a vector, and that's the direction. So x is 2, y is 3. If you want to plot this, this is what you get. But if you want to plot this, you will get a point of intersection of 2 and 3. So students, please do not repeat those mistakes. You cannot plot this on a Cartesian plane. This is a vector form, and it's a direction. That is why I've added this diagram for you to know that you cannot do this. This is wrong. Alright, we are going to learn how to plot. Now plot the points A, 2, 2, B, 6, 2, C, 4, 5, D, 0, 0, E, -5, -2, and F, -2, positive 6. So first of all, we have A, 2, 2. I normally write X on the first number and then Y on the second number so that I don't get confused. So X is 2 and then Y is also 2. So intersection of this and that, X is 2, Y is also 2. So the intersection will give us the answer. Okay. So this is the point. So an intersection gives us the point. And then we move to B, that is 6, 2. So 6 and 2. This is 2 and that is 6. So the intersection is where we plot our points. So this is A and B. Please try and label the points. A, 2, 2. B, 6, 2. Then we move to 4, 5. X is 4, Y is 5. So X is 4, Y is 5. Wherever they meet, this is the intersection of 4 and 5. So we put our point there. Then we move to D, 0, 0. 0, 0 falls on the origin. X is 0, Y is 0. So it is going to be at the intersection of X and Y coordinates. Then negative 5, negative 2. So this is x-axis, this is negative 5 and negative 2. Negative 5 and negative 2, where they meet or where they intersect is where we put our point. Then F, negative 2, positive 6. So negative 2, positive 6 will be up here. X is negative, Y is positive 6. So we put it right here. Good. So this is how we plot points. First, consider the first value. If it is positive, we start from here. The second value is also positive, so we go up in that order. Reflection of a plane figure using y-axis as a mirror line. Now, this is a complete question. And so we are going to plot these points using y-axis as our mirror line. So first, A is 1, 1. So positive 1, that is A. You write your coordinates clearly. B, 4, 3. 4, positive 3. 4, 3. That is B, 4, 3. C, 2, 5. 2 and then 5. C, 2 and then 5, where they intersect. Then we join the points. Using y-axis as a mirror line, draw the image of triangle ABC such that A maps to A1, B maps to B1, and C maps to C2. A1 was 1, 1. So when we reflect it, we will get negative 1, positive 1. So negative 1, positive 1. You can use the formula and you still get the same thing. Then 4, 3 will be negative 4, positive 3. Negative 4, x is 4, negative 4, and y is positive 3. Here is where they intersected. And then C, negative 2, positive 5. So negative 2, positive 5. Then we join the line. And this reflects here. This is y-axis. Therefore, y-axis is our mirror line. Let's use x-axis as our mirror line to see with the same question, with the same instructions. And so A, 1, 1, we have 1, 1. B, 4, 3, we have 4, 3. 4, 3. C, 2, 5, we have 2 and 5. We join the points. X-axis, we are going to get 1, positive 1, negative 1. Positive 4, negative 3, 4, negative 3, and positive 2, negative 5, and we join the points. So this is being reflected on that. Locate image points of an object under reflection in a given mirror line. Using an object and its image, determine the angle of reflection in either x, y-axis, or y equals to x, or y equals negative x in a transformation. Sometimes they will give you the question. They'll give you the image, both the image and the points, and they will ask you to determine the reflection in a line, or what is the angle of reflection. They will ask you to determine the angle of reflection. Just use the formulas, whichever one works. That means that that particular formula is the answer to that particular question. So we have 4 illustrations here with the answers. Just learn them and you will really appreciate it. So there's a review exercise. Using a scale of 2 cm to 2 units on both axes, draw 2 perpendicular axes lines OX and OY on a graph sheet. So these are the instructions, and then you are going to use y-axis as a mirror line. Just use the formulas we've learned, and then here you're going to find the equation of the line QR1. I've provided answers at the end of the video. Then we come to rotation. Rotation means turning around a center, the distance from the center to any point on the shape stays the same. So these are some of the few examples of rotation. You see, we have a center point here. There's a fan, we have a center point, and that is also a ceiling fan, and we also have a center point. So this is an example of rotation in our daily life. Things that we do, that we can use, things that we use, that we can say we can use it as an example of a rotation. These are some of the few of examples I can give. You can think of many examples. All right, we are now going to come up with our formulas for rotation. First, we are going to look at rotation through 90 degrees anti-clockwise or 270 clockwise about origin. 90 degrees anti-clockwise. Remember, anti-clockwise will go backwards. And remember too that rotation, the x and y coordinates change. So we flip here, we are going to come up with our formula. And therefore, because it's a rotation, we are going to rotate it. As you can see, this side is negative and this side is the same as this side, is positive. Therefore, rotation through 90 degrees anti-clockwise or 270 clockwise, the formula is xy maps to negative y positive x. Negative y positive x. Okay. Let's go back and then flip it over. Let's try 270 degrees clockwise. So we're going to flip here. 90, 90, 270 degrees. Okay, but we have to flip it, or we have to rotate it because it's rotation. So you could see that still y is negative and x is positive, and therefore rotation through 90 degrees anti-clockwise or 270 degrees clockwise, the formula is xy maps to negative y positive x. Okay, let's go back. Then we go to rotation through 270 degrees anti-clockwise or 90 degrees clockwise. 90 degrees clockwise, it will be here. Let's try and see. So let's flip over. Don't forget that it's rotation, so we have to rotate it. So rotation through 270 anti-clockwise or 90 degrees clockwise, the formula is xy maps to y negative x. This side is negative, so x is negative, and then y is positive. Y is positive. Okay, let's go back. Let's flip over. Then we move to rotation through 180 degrees anti-clockwise or half turn about origin. Remember, rotation through 180 and 360, x and y coordinates remain the same. So 180, 90, 90, or we can go back 90, 90. Whichever way you decide to use, you will come up with the same formula. Sorry, the same answer. So let's flip over. 90, 90, that is 180. So rotation through 180 degrees, whether clockwise or anti-clockwise, x is negative, y is negative. X is negative, y is negative. All right, let's go back. Then we move to rotation through 360 or complete turn about origin, or rotation of 0 degrees. So 360, 90, 90, 90, 90. Please don't start by counting this the first contact as 90. This is 90, 90, 180, 270, 360. Remember, rotation through 360, x and y coordinates remain the same. So we have x is positive, y is also positive. Two types of rotation. We have clockwise and anti-clockwise rotation, or counterclockwise. Rotations are generally anti-clockwise or counterclockwise. Anti-clockwise or counterclockwise from left to right pattern, and then clockwise rotation from right to left pattern. Now note the following. In any question, if the direction of the rotation is not stated, then it is assumed to be in anti-clockwise direction. So please take notes. If the rotation is not stated, whether it is clockwise or anti-clockwise, it is assumed to be anti-clockwise direction. Rotation through 90 degrees anti-clockwise or 270 clockwise about origin. This is the mapping or the formula. X, y maps to negative y, x. Illustration 1. The point Q negative 2, 3 is rotated through anti-clockwise rotation about the origin 0, 0 through an angle of 90 degrees. Find the coordinate of its image. And so we are going to substitute negative 2 and 3 into the mapping. So you're going to have negative 2, 3 maps to negative 3, negative 2. This is because this is x and that is y. But then in the mapping, y is now negative and x is positive. And so negative 2, 3 maps to negative 3, negative 2. And therefore the image point Q is negative 3, negative 2. Illustration 2. The point K15 is rotated through 270 degrees about origin. Find the coordinate of the image of K1. In the same way, 15, we flip it. Y is negative, x is positive. And therefore the image K1 is negative 5, positive 1. Rotation through 180, anti-clockwise or half turn about origin 0, 0. The point or the mapping is xy maps to negative x, negative y. Illustration 1. The point K34 is rotated through 180 about the origin 0. Find its image. So when we substitute 3 and 4 into the mapping, we will have negative 3, negative 4. And therefore the image point K1 is negative 3, negative 4. And then again, the point R, negative 2, negative 4 is rotated through half turn about the origin 0, 0. Find R1. When we substitute the values into it, we are going to get negative 2, negative 2, negative 2, negative 4. And therefore negative, negative will give us positive 2, negative, negative 4 gives us positive 4. And therefore the image point is R1, 2, 4. Rotation through 270 anti-clockwise or 90 degrees clockwise about the origin. The mapping is xy maps to yx, y negative x. Illustration 1. The point K34 is rotated through 270 degrees about origin. Find its image. And therefore when we substitute 3 and 4 into the mapping, we will have positive 4 and negative 3. The image point K1 is 4, negative 3. Illustration 2. The point R, negative 2, negative 4 is rotated through 90 degrees clockwise about origin. Find R1. So when we substitute, we are going to get negative 4, negative, negative 2. And negative 4 will give us negative 4, and negative, negative 2 gives us positive 2. And therefore the image point is R1, negative 4, positive 2. Rotation through 360 or complete turn about the origin, or rotation of 0 degrees. Either of them is the same. 360 or complete turn about origin, or rotation of 0 degrees. The mapping is xy maps to xy. The x and y coordinates are the same. They are maintained, or they remain unchanged. Illustration 1. Find the image of P, negative 3, 5 when rotated through 60 degrees about origin. And therefore, this is the mapping. So you're going to get negative 3, 5 maps to negative 3, 5. And therefore, the image of P1 is negative 3, positive 5. Then we come to illustration 2. The point Q2, -3 is rotated through 0 degrees about origin. Find the coordinates of its image. So just substitute +2, -3 into the mapping, and we are going to get 2, -3. Therefore, the image of Q1 is 2, -3. Using an object and its image, determine the angle of rotation in the transformation. So here again, they can give you a point and its image, and they will ask you to determine which angle of rotation was used. So still use the formulas or the formulae to see which one works. Whichever one works is the answer. So let's look at illustration 1. If A22 maps to A, A1 2, -2, B 6, 2 maps to B, B1 2, -6, and C 4, 6 maps to C1 6, -4, what is the angle of rotation of the transformation? When you look at it well, it's clockwise rotation through 90 or counterclockwise through 270 degrees. So try your hands on illustration 2 as well. Now, this is a review exercise 3. I've provided the answers at the end of the video. So these are the answers. Review exercise 1, review exercise 2, review exercise 3. But please work all the review exercises before you come and check whether your answers are correct. Please subscribe, share, and enable notification. Thanks for watching, and expect part 2 of this topic within 2 to 3 weeks. Thank you and have a nice day. Bye-bye.